For thousands of years, humans have looked at the night sky, their eyes drawn to a faint red dot. That dot was Mars. A world so close, yet so far. A world that has inspired myths, stories, and dreams of exploration. But today, the question is no longer about stories, it is about survival. What if Earth one day becomes unlivable? Could Mars be our next home? In this journey, we will travel across space and imagination, exploring the science, the challenges, and the possibilities of human life on the Red Planet. Stay with us until the end, and if you want more journeys into the mysteries of our universe, don't forget to subscribe to our channel, Star Sky Science. Our adventure begins now. Before we imagine living on Mars, we must first understand the planet itself. Mars, often called the Red Planet, is the fourth world from the Sun. It lies at an average distance of about 225 million kilometers from Earth. Sometimes, when the orbits bring us close together, Mars can appear as a bright, glowing red star in the night sky. The redness of Mars comes from iron oxide rust covering its surface, but beyond the color lies a planet filled with mountains, valleys, deserts, and even polar ice caps. It is, in many ways, both familiar and alien. For ancient civilizations, Mars was more than just a planet. The Babylonians associated it with their god of war. The Romans named it after their own war god, Mars. Its red color reminded humanity of blood and conflict. But to others, it represented mystery, and perhaps even life. As telescopes improved in the 17th and 18th centuries, astronomers began to study Mars more closely. They saw strange dark lines on the planet's surface, which some believed to be canals, artificial structures built by intelligent beings. For a time, Mars was thought to be a world alive with civilizations far older than ours, but with the invention of more powerful telescopes, and later, spacecraft missions, those myths faded away. The canals were simply optical illusions. Mars was not a world of alien empires. It was a barren desert, yet not all hope was lost. In the 20th century, as rockets reached space, Mars became the prime target for exploration. The first flybys revealed a dusty, lifeless surface. Later missions, like NASA's Viking landers in the 1970s, confirmed the absence of obvious life: no plants, no animals, just rocks, sand, and silence. But silence does not mean emptiness. Scientists found evidence that Mars once had rivers, lakes, and perhaps even oceans. Billions of years ago, Mars may have been warmer and wetter, a planet that could have supported life. Today, rovers like Curiosity and Perseverance continue this search. They drill into rocks, analyze soil, and even try experiments to produce oxygen from the Martian atmosphere. Each mission brings us closer to answering the ultimate question: could humans truly survive here? But survival requires more than curiosity. Mars is not Earth. Its environment is hostile, its atmosphere deadly, and its distance immense. To imagine living here, we must face its harsh realities. To live on Mars is not just a dream of science fiction, it is a battle against nature itself. If humans were to step onto the surface of Mars without protection, they would not last even a minute. Let's explore why. First, the atmosphere. On Earth, we breathe oxygen-rich air with enough pressure to keep our bodies balanced and alive. Mars, however, has an atmosphere made up of more than 95% carbon dioxide, with less than 1% oxygen. If you tried to breathe here, you would suffocate instantly. And even if oxygen were somehow provided, the atmospheric pressure is less than 1% of Earth's. That means your blood would begin to boil at body temperature. To survive, we would need specially designed suits and habitats with Earth-like pressure. Second, the temperature. Mars is a frozen desert. The average surface temperature is -60 degrees Celsius, but it can drop to -125 at the poles during winter nights. Even on a warm afternoon near the equator, it may barely reach 20 degrees Celsius, only to plummet at sunset. Any attempt to live here would require advanced insulation, heating systems, and constant energy supply. Third, radiation. Earth is protected by its magnetic field and thick atmosphere, which shield us from deadly solar and cosmic radiation. Mars lost its magnetic field billions of years ago. With little atmospheric protection, radiation bombards the surface daily. Long exposure would damage human DNA, increase cancer risks, and weaken the body. Any colony on Mars would need underground shelters or heavy shielding to survive. Fourth, water. Life cannot exist without water, and while Mars has frozen water at its poles and beneath its soil, it is locked away in ice or trapped in minerals. Extracting and purifying this water would be a monumental task. Yet, without it, humans cannot drink, grow crops, or create fuel. Fifth, dust storms. Unlike Earth's localized storms, Martian storms can cover the entire planet. Dust particles, though tiny, are sharp and toxic, made of fine chemicals like perchlorates. These particles can clog machines, damage lungs, and block sunlight for weeks. For solar-powered systems, this could mean total energy collapse. And then comes distance. Mars is not a short trip away. Depending on planetary alignment, it takes between 6 to 9 months for spacecraft to travel there. That means every supply mission would be delayed by years. Any colony would need to be almost completely self-sufficient. So, when we imagine humans living on Mars, we must remember, this is not simply moving to another continent or another island. It is trying to build life on a world that wants to kill us at every step. And yet, history shows that humans have always survived the impossible. From crossing oceans to landing on the moon, our species has defied nature's limits. The question remains, can we do it again, this time on an entirely different planet? Now that we understand the dangers of Mars, the thin air, the radiation, the freezing cold, the next question is, how can humans survive here? If Mars is so hostile, what kind of home would we need to build to make it livable? The first challenge is shelter. Astronauts cannot simply land, pitch a tent, and start living. Mars requires protection from the cold, protection from radiation, and protection from the storms. Scientists have proposed several solutions. One idea is to use 3D printers to build homes from Martian soil itself, called regolith. This would save us from transporting tons of building material from Earth. Robots could arrive before humans, printing dome-shaped habitats with thick walls strong enough to block radiation. Another idea is to live underground. Mars has natural lava tubes, giant hollow tunnels left behind by ancient volcanic activity. These underground caves could serve as ready-made shelters, shielding colonists from deadly cosmic rays while maintaining a more stable temperature. Inside, humans could build living quarters, laboratories, and greenhouses. But a shelter is only as good as the air inside it. Mars has no oxygen to breathe. To survive, we must create it. One possible solution is to split oxygen from carbon dioxide, which makes up most of Mars' atmosphere. NASA has already tested a device called MOXIE on the Perseverance rover, successfully producing small amounts of breathable oxygen. Scaled-up versions of this machine could one day supply entire colonies. Food is another necessity. We cannot ship endless supplies from Earth. Colonists must grow their own crops. But farming on Mars is no easy task. The soil is toxic, full of perchlorates harmful to humans. Scientists propose either cleansing the soil or growing plants in hydroponic systems using water and nutrients without soil. Greenhouses, powered by artificial light, could one day produce vegetables, fruits, and even grains. Imagine astronauts eating a salad grown on Mars, the first steps toward independence from Earth. And then comes water. Without it, there is no life. Fortunately, Mars does have water frozen in its poles and locked beneath its surface. By heating the soil or drilling into ice deposits, colonists could extract this vital resource. Advanced filtration systems would recycle every drop, just as the International Space Station already recycles water, even from urine and sweat. On Mars, nothing can go to waste. Energy is the lifeblood of any colony. On Earth, we rely on fossil fuels and renewable sources. On Mars, solar power is an obvious choice, but dust storms pose a serious threat, blocking sunlight for weeks. At ISY, nuclear power is considered essential. Small nuclear reactors, already being tested on Earth, could provide a constant and reliable energy source, keeping habitats warm and systems running, even in the longest storms. Finally, we must think of health. The human body evolved for Earth, not Mars. Lower gravity will weaken bones and muscles over time. Colonists would need daily exercise in special gyms, along with medical facilities to handle emergencies. Communication with Earth would take up to 22 minutes one way. meaning doctors must rely on artificial intelligence and robotic assistance for urgent care. Every element, air, water, food, shelter, and energy must work together in a delicate balance. If even one system fails, the entire colony could be at risk. Mars will not forgive mistakes, but with the right technology, humans can transform a deadly world into a fragile but functioning home. For the first settlers, life would not be easy. It would be confined, routine, and full of risks. Yet, within these domes and tunnels, humanity would be writing the opening chapters of a new story, the story of a species learning to live beyond Earth. Imagine waking up on Mars. Instead of the blue sky of Earth, the first thing you see outside the window of your habitat is a dusty red horizon. The sun appears smaller here, shining with only half the brightness it does on Earth. The day is almost the same length as ours, 24 hours and 39 minutes, so mornings, afternoons, and evenings still exist, but every moment feels alien. Inside the habitat, life is carefully structured. Colonists would live by strict routines. The first priority is safety checks. Air pressure, oxygen levels, water supply, and radiation shields must be monitored daily. A small error could mean disaster. Unlike Earth, Mars does not forgive mistakes. Work would consume much of the day. Some colonists would maintain life support systems ensuring oxygen is produced and water recycled. Others would work in greenhouses, tending to plants that may one day provide full meals. Scientists would study the Martian soil, atmosphere, and weather. Engineers would repair equipment, test new machines, and prepare habitats for expansion. Every job has meaning. Every task is survival. Outside activities would be rare and dangerous. To step beyond the safety of the habitat, colonists must wear pressurized suits. The thin atmosphere offers no protection, so every outing feels like a spacewalk. A trip outside might be to repair solar panels, explore nearby terrain with rovers, or collect samples. Each excursion is planned with military precision. Time is limited, and mistakes are costly. Meals would be simple, especially in the beginning. Much of the food would still come from Earth-dehydrated packs, rehydrated with precious water. Slowly, as Martian greenhouses improve, fresh food would supplement these supplies. A bite of a Martian-grown potato or tomato would not just be history. Exercise is critical. In Mars' weak gravity, bones lose density and muscles shrink. Colonists would spend at least 2 hours a day using resistance machines and treadmills designed to mimic Earth's gravity. This routine would not be optional, it would be survival. Free time would be precious. Colonists might read, write journals, play digital games, or look out at the Martian landscape. Communication with Earth, though delayed by up to 22 minutes, would bring news, messages, and video calls. Every signal from home would remind them of what they left behind. Psychology would be just as important as technology. Living in small groups, isolated millions of kilometers away, could be mentally exhausting. Colonists would need community, traditions, and celebrations to stay motivated. Birthdays, holidays, or the day of arrival on Mars could all become special rituals. Humanity's spirit would be tested as much as its science. Night on Mars would feel surreal. The sky would glow with stars far clearer than on Earth. 2 tiny moons, Phobos and Deimos, would rise and set quickly, casting faint shadows across the red plains. Inside the habitat, colonists would prepare for another day, knowing that every sunrise is both a victory and a challenge. Life on Mars would not be comfortable. It would not be easy, but it would be meaningful. Every action, every moment, would carry the weight of history. These pioneers would not just be surviving, they would be building the foundation for generations to come. The first true citizens of another world. The early decades on Mars will be about survival, but once the foundations are secure, humanity will begin to dream bigger. The next step will not just be habitats, it will be cities. At first, these Martian cities may look nothing like cities. On Earth, instead of skyscrapers and open streets, they may exist underground, protected from deadly radiation. Long tunnels and vast caverns could be carved into the rock, filled with pressurized chambers where thousands of people live, work, and play. Imagine a subway system, but instead of trains, it is life itself that flows through the tunnels. Above ground, giant domes of glass and metal may rise, shimmering in the thin sunlight. Inside them, artificial parks, lakes, and even forests could exist. Colonists would walk under a protective roof, breathing air that humans created, surrounded by green life that reminds them of Earth. For the first time, people on Mars might feel at home. Energy will shape these cities. Solar farms stretching for kilometers would collect the weak sunlight. Nuclear reactors might provide steady power through dust storms. Future technologies like fusion power could make Martian cities shine brighter than anything built before. Water will be the lifeblood of these cities. Ice beneath the surface will be mined and purified, filling reservoirs that sustain entire communities. Recycling systems will ensure that not a single drop is wasted. In time, water could flow through pipes, fountains, and even artificial rivers. Economy will also emerge. Some colonists will mine valuable minerals from Mars' crust. Others will develop industries that Earth cannot match, like manufacturing in low gravity or creating fuel for interplanetary travel. Mars could become a hub for the new space economy, exporting resources to Earth and beyond. As populations grow, culture will evolve. Mars-born children will see the planet not as a frontier, but as their home. They will speak of Earth as a distant world, much like we now speak of ancient history. Art, music, literature all will take on a Martian identity. A new civilization will be born under the red skies. Yet, challenges will remain. Cities will need protection from dust storms, meteors, and radiation. Expanding too fast could risk collapse, but with careful planning, humanity could create settlements that last for centuries. One day, when people walk through a Martian city, they may see familiar signs of life: marketplaces, theaters, schools, hospitals, and playgrounds. Families laughing together. Children running under the glow of artificial sunlight. Streets alive with voices and footsteps. What began as survival will have transformed into something greater: the creation of a second cradle of human civilization, the first true cities beyond Earth. Survival in domes and underground tunnels is only the beginning. Humanity has always dreamed bigger. And the ultimate dream for Mars is not just to live in shelters, but to transform the entire planet into a world that feels like Earth. This is the idea of terraforming. Terraforming means reshaping an alien planet so humans can live there without spacesuits, without domes, and without fear. It means changing the air, the temperature, the water cycle, and maybe even creating oceans. But how realistic is this dream? First, the atmosphere. Mars has a very thin atmosphere made mostly of carbon dioxide. To make it breathable, we would need to add enormous amounts of oxygen and thicken the air. One idea is to release greenhouse gases into the atmosphere, warming the planet and melting its frozen water and carbon dioxide. This would trigger a chain reaction, releasing even more gases and thickening the atmosphere over centuries. Second, heat. Mars is cold, far colder than Earth. To make it warm enough for liquid water, we might use giant mirrors in orbit, reflecting sunlight down to the surface. Others imagine powerful machines pumping greenhouse gases, or even detonating controlled nuclear explosions to release trapped carbon dioxide from the soil and ice. Third, water. Mars has plenty of frozen ice at its poles and beneath its crust. If we could warm the planet, much of that ice could melt into rivers, lakes, and maybe shallow oceans. Imagine standing on Mars, not in a desert, but near the shore of a new Martian sea. But the hardest part is oxygen. Plants, algae, and microbes could slowly produce oxygen if we seeded Mars with life. Yet, this would take thousands, maybe millions of years. For generations, humans would still need oxygen masks or habitats until Mars was truly breathable. Some scientists believe terraforming is possible with enough technology and time. Others argue it may never happen. Mars is small, and without a magnetic field, it cannot hold a thick atmosphere for long. Even if we create one, solar winds may strip it away again over time. Yet, the dream persists. Terraforming is more than science. It is a vision of transforming a dead world into a living one. For some, it is the next step in humanity's destiny, to spread life where none exists. For others, it is a reminder of the challenges we face, even here on Earth, where we struggle to protect the planet we already have. Imagine standing on Mars centuries from now. The sky no longer pale and thin, but blue. The air warm and breathable. Green fields stretching across valleys. Oceans glimmering under the sun. Children playing outside without helmets. running freely on alien soil. If terraforming succeeds, Mars would no longer be a desert, it would be a second Earth. But until then, Mars reminds us of a hard truth: creating a new Earth is far more difficult than protecting the one we already have. Throughout history, humanity has looked to the skies and wondered what lies beyond. From the first sailors who crossed uncharted oceans to the astronauts who stepped onto the moon, the desire to explore has always defined us. Mars is simply the next horizon, but Mars is more than just a destination. It is a test of what we can achieve together. To live there, humans must combine science, engineering, courage, and imagination on a scale never seen before. No single nation can own Mars. It will take the effort of all humanity's scientists, engineers, dreamers, and explorers to make this impossible journey possible. Why does Mars matter? Because it reminds us that we are capable of more than survival. We are capable of growth, of discovery, of reaching for the impossible. Mars is a symbol of the human spirit, the drive to push boundaries, to adapt, to dream, and to create a future that is larger than ourselves. Mars also forces us to reflect. On Earth, the more we plan for another planet, the more we realize how rare and fragile our own world is. Earth already has everything we need: air, water, warmth, and life. By dreaming of living on Mars, we learn to value the gift of home even more. Still, the dream of Mars persists, not because it is easy, but because it is hard. The challenges ahead are enormous: radiation, isolation, technology, and the unknown. Yet, every great achievement in human history once seemed impossible. Flying once seemed impossible. Reaching the moon once seemed impossible. Now living on Mars seems impossible. But perhaps one day, it will simply be history. Imagine, generations from now, looking back at this moment, the moment when humanity first dreamed of becoming a multiplanetary species. The moment when we decided that one planet was not enough. Mars will not just be a new home. It will be a new beginning, a place where our descendants write their own history, build their own cities, and create a new chapter in the story of life. So, what if humans could live on Mars? The answer is simple. We would not just survive, we would redefine what it means to be human. If you enjoyed this journey through the possibilities of life on Mars, make sure to subscribe to my channel Star Sky Science for more science and space documentaries. The universe is vast, and this is only the beginning.